we'll go ahead and get started. So Ricardo and Marlena, you guys ready?
Do you want us to work on it?
Yeah.
Okay.
So I'll put um, you two in charge of this question, and then when uh, get ready, go ahead and tell me in the chat that you're ready, and then we'll move on. And I'll ask you what you came up with. Just to be clear, um, you almost surely need a calculator for this one. Okay? All right. Do you guys have any questions before I let you go for 5 minutes? No questions? Okay. All right. See you guys in 5 minutes then.
Working.
Okay. Well, what about you, Marlena? How are you doing?
I'm still working on it also.
Okay. So, Ricardo, let me chat with you for a minute. Are you there?
Yeah, I'm
Yeah.
having
Okay.
difficulties with the question.
Okay. Well, let's read it together. While visiting family in Mexico, your professor has a budget of 218 pesos that he spends on tacos and tequila. The price of tacos is 6, the shot of tequila is 7, and during the visit, the price of tacos changes to 9. This is a basic prompt for like all the rest of the questions. And then it says, assume your professor has a Cobb utility function with tacos parameter 20 over 100. So that's 0.2, right? You with me, Ricardo?
Yes.
And so this says, how much utility does your professor receive from consuming 6 tacos and 14 shots of tequila? So for this question, just to let you know, there's a lot of extra information. The key for this question is um, this. Well, let me see if I can highlight it for you. Is this Cobb Douglas utility function? Okay. So do you remember our Cobb Douglas utility function? What its basic form is?
Yeah. AX over BX equals PX over PY.
No,
No?
that's the tangency condition. You gave the marginal rate of substitution, but remember we said the utility
Oh,
is
would be X to the power of 0.2 for this question
yeah.
times
If
Y to
x
the
is
power of
tacos,
0.2.
0.2, right, times y raised to the what?
Power of 0.2 as well. Or
No,
no, because it only gave us for tacos, right?
right.
So it'd be 0.8.
Yeah, 0.8 because remember that
Or,
these two exponents have to sum to 1. So if we know one, we know the other one, right?
yeah.
Right? So you just have to 1 minus zero point 0.2 is 0.08, so if they sum to 1. So this is our utility function, and then we're just being asked, and I'll just put some parentheses in here to be clear. Um, lest it cause confusion. So is that clear?
Yes.
Right. So now we're asking for the utility of a specific consumption bundle, right? And that consumption bundle is X is equal to what?
6. Or for
6.
Toxo 6, yeah.
Yeah, 0.2, right?
And then
Times
14.
14 to the 0.8 power.
11.81.
Oh yeah, so see that's what I'm saying. That's why I started to worry about you all because it's not really a hard problem, right? It's just a simple calculation. right?
Yeah.
You're like, seems like a hard problem. It's not really. I mean, come on. Of all the problems that you faced, what do you think, Ricardo? Is this one tough?
No, it's pretty simple.
Yeah. And Marlena, did you get the same answer?
Yes, I also got the 11.81.
11.81. Now, um, just for a sanity check, I'm gonna go back and um, check on Ignithium to see if it got the same answer. And this is what I got from Ignithium. So, um, yeah, that's good, right? Is there anybody that's concerned about the difference between the 11.82 and the 11.81? Does that give you pause, Ricardo or Marlena?
I mean, not really. I mean, it should be fine if we put 11.81, right?
Yeah, if we put 11.81 in the submit button and hit in the little box and hit submit, it would say, yay, you got the right answer. So this is within rounding error. It's no big a deal. So before we move on, I want to ask, does anybody have any questions about this? Any questions? No. Okay.
Oh wait, I have a question.
Okay, Hannah.
Why is 14 raised to 0.8? I think I missed that part.
Well,
Is it
it's
because
just
is it because there wasn't an increase?
no. So this is kind of like a maybe what, and I'm gonna try to explain it in more detail. But maybe is like what's the disconnect here, right? So this utility function is Cobb-Douglas form,
Mm-hmm.
right? Cobb-Douglas says, and I'll write it again down here. And remember, not all utility functions are Cobb-Douglas. We're just picking Cobb-Douglas because it's handy for lots of reasons. But it's a raised to the alpha times y raised to the beta.
And then you found the beta with 1 minus 0.2.
Yeah, because we also know where a plus b is equal to 1. That's what makes it Cobb-Douglas. If you had a plus b equal to some other number, which is possible, I'm not going to say, that never happens. It's just kind of unusual. There would have to be some like reason given, but you could have the sum of the exponents be equal to, I don't know, 2.5 or 31, or, pick your favorite number.
Mm-hmm.
But then it wouldn't be Cobb-Douglas anymore. It would be, Cobb-Douglas has these. So I don't know if you're kind of familiar with the language, but because you're in an applied math degree, it's a good time to expand the vocabulary. But have you heard, Hannah, like of the term a variable, right?
Yes.
Okay. And can you differentiate between a variable and a parameter?
Is parameter more like, I guess more of like a function that's given with the question, whereas a variable is like A or B?
No. So like the variables here are X and Y because during our analysis, they can change. We don't have to have 6 tacos and 14 shots of tequila, right? We could have 3 tacos and 12 shots of tequila, or 20 shots of tequila and 5 tacos, right? So the variables are things that can change within the analysis that you're doing. But parameters are assumed to be constant while you're performing the analysis. So it doesn't mean the parameters could, in all possible universes, never change. But remember, and this is going to be kind of a little bit of a like maybe it'll click. I don't know. But for us, remember the utility is supposed to represent the preferences of a person, right?
Mhm.
Like Hannah's preferences. And guess what? This is like an unstated assumption in all of the economic analysis that you're ever going to do. But when you're analyzing the preferences of a consumer during the period of analysis, those preferences are assumed to not change. They're assumed to be constant. Hannah knows her preferences as of this moment. And if we measure her preferences right now by doing some survey or something like that, and then we go on to analyze Hannah's preferences, her preferences cannot change while we're doing our analysis. Because otherwise, right, we would have no hope
Mhm.
of predicting once our analysis is done how many tacos and how much tequila that Hannah's going to choose. You see what I mean?
Mhm.
So since the utility represents Hannah's satisfaction from consuming different combinations of tacos and tequila, then we have to have A and B constant while we're analyzing that decision, because otherwise that would mean your preferences were changing, right? So we would look at the same bundle, like 6 tacos and 14 shots of tequila, and if A and B were changing, we would end up getting different. I mean, this 11.81, that's your utility for consuming that combination of tacos and tequila. So, if we put in a different A and B and the same 6 and 14, we'll get a different number out,
Mhm.
right? And then also, I mean, hopefully this is again going to click, and then it's less about memorizing and more about just like knowing, right?
Mhm.
But remember, this 11.81 is kind of like, well, I mean, it literally is, but it's sort of maybe unfamiliar in this context, but it's like your ranking. And I should say it is your ranking, but I'm going to say it's like, because I'm making a slightly different association, which is, so it's like your ranking of that consumption bundle, right? You're saying, if I were to ask you, normally I would ask the question something like, hey, Hannah, on a scale of 1 to 10, how do you feel about 6 tacos and 14 shots of tequila? And you would say something like, oh, that's an 8, right? Or it's an 8.5. But this is a little bit more like, remember, for Cobb Douglas, we don't have any bound. So we don't have any upper level, like, on a scale of 1 to 10, right? We have,
Mhm.
on a scale of 0, which is what we could get out of this if we put in 0 shots of tequila and 0 tacos, that's what we would get out of this function, right? 0 to the 0.2 power times 0, 0 times anything is 0.
Yeah.
So we're just going to get 0 out of it. So it goes from 0 to infinity, right? Because if I keep putting bigger and bigger numbers in for X and Y, your utility will just keep going forever. It'll go up. So our scale is from 0 to infinity, and you're saying, oh, my ranking is 11.81. So, however you want to interpret that. But if you want to kind of, make it like a cleaner interpretation, then just give yourself some upper bound. Suppose I say something like, this is like your answer to, okay, Hannah, on a scale of 0 to 100, how do you feel about 6 tacos and 14 shots of tequila? And your answer is, oh, I feel like it's like an 11.81, right?
Mhm.
And you know what the value of that is again, if I have multiple consumption bundles, like again, if I ask you like about movies, right? I don't know, do you have a favorite movie?
When I was little, I liked the original Willy Wonka.
Oh, okay. The original one.
Yes.
So is that not the live action one, but the animated one from like 1965 or something?
No, I mean, because they made the one with Johnny Depp.
Is that the one that you like?
No, I like the one with
Oh,
the guy with the old curly hair.
oh,
I
okay.
don't know his name.
It's like the
He's
Hallmark
Stivo.
special version or whatever.
Yeah. I don't
Yeah,
really watch many movies now, but if I could pick one, I guess it's still that.
well, my daughter's ages 21, 18, and 13. Yeah, Gene Wilder, that's right.
Yes, thank you.
Yeah. So my daughter's like favorite childhood films are the Barbie movies.
Oh my god, my mom wouldn't let me watch Barbie.
Oh, really? See, I
I
didn't.
actually do like some of them though; they were good.
So they like a lot of them are like remakes, like Barbie, the Princess and the Pauper, and like one of the other ones I remember because I used to have to watch them too. Like Fairytopia.
Yep,
So did you ever watch Fairytopia?
I'm pretty sure I did.
Do you remember
Just because I
the
like fairies.
Barbie had a pet in that movie named Bibble?
No, I don't.
That little
remember
fur ball or something like that.
Yeah, and that's what our dog was named.
that.
So you can tell like how deep it was. So the only point I'm making is that like think of like your favorite movie, and I say on a scale of 0 to 10 or 1 to 10, how do you rank your favorite movie of all time? You're probably going to say like a 9.9 or something like that, right? And then I don't know if there are other movies that you also like, but you would probably rank them lower, like 9, an 8. This is a 7. And from a decision perspective, how does that help me as an analyst? Well, if I know that, Willy Wonka is your top one, then I know if I, give you a choice, like I'm, setting some sort of TV schedule, or I'm somebody working at, HBO, and I put these, HBO 1 and HBO 2, these time slots in there, and I give you the chance to watch Willy Wonka, and then I put other things in there you don't like as much, then I know Hannah's going to pick Willy Wonka, right?
Yes.
Yeah. So this is the same thing. The only value of the 11.81 is we know if we offer you something else, like in this case, it's pretty easy because remember the preferences for Cobb Douglas are monotonic. Do you remember what I mean by monotonic, Hannah?
Isn't that when they want both the goods the same amount?
No, monotonic means if I give you more, your utility goes up.
Mm-hmm.
So if I put in 15 shots of tequila instead of 14, or I put in, 7 tacos instead of 6, I know the number that's going to come out is going to be bigger. So I know you like that more than having less of the goods. So if I want to, make sure that I get Hannah to buy the taco bundle, right? Or the taco tequila bundle, and I offer her a bunch of different ones. If I offer one that's got more, then I know she's going to choose that one. You see what I mean?
Yeah.
Okay. So anyway, and to kind of just drive this point home a little bit more, I want to kind of connect it up, and I'll say this because this is coming to an exam near you soon. You guys are probably not familiar with that phrase. When I say it's coming soon, what that's about? Anybody? Ricardo? Marlena?
No, I didn't. I don't get it.
Yeah, they used to see. This is dating, right? So they used to do advertisements for movies that were going to go to theaters, and people didn't stream stuff, so they would say coming to a theater near you. and
Oh, okay.
it means it's it's opening next weekend. It's like, so you're supposed to get excited. But so remember, and I could go ahead and I'll go ahead and just for sake of doing it, there's y. And so are you following everything that I'm saying, Ricardo? You good?
Yes.
So I'm gonna go ahead and put our consumption bundle here. Okay, so I'm looking from 0 to 6 tacos and 14 shots of tequila. That's a point like, let's see if it's gonna let me draw it. That's like about right here. Okay. So does that look like a good consumption bundle for you, Hannah? You see why I put the dot on the graph?
Yeah, I see it.
Okay. I mean, does it make sense, right? That's the bundle that includes 6 tacos on the x-axis and 14 shots of tequila,
Yeah.
right? And then remember, let's see, hopefully I can do this well. Some indifference curve passes through that point, and to actually be really clear about it, right? That point is actually part of some indifference curve. Okay. Does that look good, Hannah?
Looks great.
And then the utility associated with all of the points on that indifference curve, what is it? You want to tell me?
11.81.
Yeah. So all of those, including the one that we calculated the utility for, are going to give us a utility of 11.81. Okay.
Mhm.
So any other questions? Questions?
That's it for me.
Okay. And you know what? Thank you so much, because if you didn't ask the questions that you asked, then there would have been a lot of other people that didn't ask and were just confused. So
Mhm.
good job.
Thanks.
Sure. Okay. Next question. And okay. Now, this question, first of all, I will, let's look who's here. Arjan, you here this morning?
Yeah.
Yeah. Okay. You see the question, right?
Yeah.
Yeah. And let's go with Jian Yu. You here? Jian Yu? Okay. How about Tanish? You here? Tanish? Okay. Okay. Let's do this. Okay. Okay. How about Mauricio? Dun, dun, dun. Okay. So I should start kicking you guys if you don't respond. But I won't this time. But I'll ask one more person. How about Ziyuan? Are you here? Okay. Okay, Joseph, you there?
Yeah, I'm here.
Okay. So I'll ask you to be a lead, Joseph, and for Arjan to be a lead on this question. And then go ahead and work on it, everybody, for, you know, this one is probably more, a little bit more like a 10-minute question. Well, we'll say 7 minutes. But I'll ask you first, do you have any questions on getting started, Arjan, or so? Just work on the question, Jianyu. Okay. So, but does anybody have a question about how to get started, or are you guys good?
I think I'm good.
Okay. Okay. Anybody? Anybody? Okay. So I'll give you a few minutes and I'll come back and check on you. When you're ready, just type ready. Okay, I'm back. How's it going? Arjan?
I was kind of struggling, to be honest.
Okay. And what about you, Joseph?
Well, I came up with 14, but I'm not at all confident in that.
Okay. And does anybody else have an idea? No. Okay. Okay, so Arjan, are you with me? And Joseph? Sue.
Yep.
Okay. Now, there's only one way to solve this problem. Oh, and Derek's got 11.47. Okay, nice. I don't know, Derek, because I haven't calculated it first. But remember, Joseph, the analogy I made at the last lecture, where I said these types of problems, right? They are like supply and demand equilibrium problems. Do you remember me talking about that?
I think so, yeah.
Yeah, and the point is, and I'm just going to draw this really quickly. This is just a little sketch, but this is what you should have in mind. What we're looking for is, let me do the budget constraint in blue. We've got, for this consumer, there's a budget constraint. That's one of the lines. That looks kind of like a demand curve, right?
Yeah.
Right. And it looks like that because it's also a linear equation, just like demand is that we work with most of the time. Demand doesn't have to be linear, but all the examples we've worked with, it was linear. And then we also have an indifference curve, and I'll try to draw it the best that I can. And like that. Okay. Does that make sense, Joseph?
Yep.
Right. So what we have to do is we have to find out, we're looking for the point where those two equations meet.
Gotcha. Yeah.
Right? Just like in demand and supply, we're looking for where demand and supply intersect. That's a single point. Here, we have a place where an indifference curve and the budget constraint meet. It's not an intersection, like I said, it's a point of tangency, but it's one point that simultaneously satisfies both of these equations. Okay, so we need two equations, and we have to find where those two equations are satisfied. In our case, the two equations are what I called a tangency condition. So I'm just going to say that as tangency. And the other one is the budget exhaustion condition. I'm just going to call that the budget. Okay. And remember, so this is where the consumer's income or their budget is equal to px times x plus p py times y. And then the tangency, remember, this one's a little bit more complicated. It's alpha y divided by beta x. Is equal to px over py. And again, that's because this left side of the equation, right here, that left side is the slope of the indifference curve, and the right side is the slope of the budget constraint. And so hopefully, if you haven't figured it out already, are you with me, Joseph?
Yeah.
See, I'm pointing to the indifference curve's slope, and the slope changes because it's a nonlinear equation depending upon where you are, right?
Yeah.
And what we can say about this point is that's where the slope is equal. Now I'm doing the slope of the budget line as I follow it along, but notice that slope, because it's a line, is constant,
Mhm.
right? And at this point where they meet each other at the point of tangency, this curve's slope is equal to, and by the way, I don't know if you know this or not. Like I said, generally, all of these graphs are called a locus of points, right?
Mhm.
But they're also, if it's locus of points, where for each point in the domain, there's one point in the range, then they're going to call it a curve. And so a straight line graphed is also a curve. Are you following me, Joseph?
Yeah.
So here, the slope of both curves is the same. And that's our tangency condition. So we'll talk a little bit more about it in lecture, like why that's true. But right now, you just kind of have to take it on faith that AY over BX is equal to the slope of the indifference curve. So now you have these two equations and these two unknowns, and you have to go ahead and just populate it with all of the values, and then you'll have one equation. So Arjan, do you follow?
Yeah, I'm following.
Yeah. Okay. So what I recommend, because we're running low on time here, is that y'all take a screenshot of this, and then I'm going to do one other thing, which is I'm going to go ahead and give you the answer to this one so that you can work through it. And then next time we get together, we can verify the answer. Okay. So, okay. So that's the answer hit. So you were close, Derek, a little bit off, but we'd have to work through the math to see how.
Yeah. All right.
Okay. So maybe just, check your math, and then you'll see. Maybe the only thing that I can think of, let's see.
I used the price change of 19 versus 11, so I don't know if that makes a difference.
Well, see, right here in this question, we're just asking how many shots of tequila
Right.
does the professor purchase, right? And normally, if you look through the sequence of these questions, it's referring to the original condition, which is when tacos are 11 pesos and tequila is 15 pesos. At that point, what's the professor going to decide to do? And then it's this other part where it asks about the change is another condition, right? And we're going to talk about that more in lecture, but I guess the main point is just that right now we're just concerned about this initial situation. So that's why you have to kind of read these questions carefully. If you read the rest of the questions on Ignithium, you'll see that there is the like after the price change. It'll say how many shots after the price change, and that sort of thing. But right now we're just considering the the initial situation. Okay. Are you okay, Derek?
Yeah.
Yeah. Okay. So let's come back and we'll finish this one up on Thursday, and I'll go ahead and stop for today on the activity, and then we'll go to lecture. Okay.